Okay, now let's talk about limit at infinite, okay? It's really similar with the previous problem, but keep that in mind. This is different, okay? In the previous problem, your x goes to some specific point, right? But this one, x goes to the infinite or minus infinite. Does it make sense? It's different problem. That's why the name of this problem is limit at infinite, okay? To understand this one, then you have to remember whenever you have like big number on your denominator, there we go. Like that. What happened? Your x is getting bigger, right? Then we're going to plug in we can start from 1, okay? 1 over 1 is 1. 1 over 10 is 0.1. 1 over 100 is 0.01. 1 over 1,000 is 0.001. And what does that mean? Whenever you just increase your denominator, what happened? Your number is getting smaller and smaller, smaller, and getting approach to 0. But keep that in mind. Never equal 0, but getting approach to 0. But in limit sense, we can say limit value equals 0. That means approach to 0, okay? But keep that in mind. Whenever you have like a big number on your denominator, it must be equal 0, okay? So let me come back to the problem, okay? So in this problem, we have to understand about the speed of your function, okay? When x goes to infinite, okay? So look at your numerator, okay? 1 is just 1, but x squared is getting bigger and bigger and bigger, okay? Which means if you have like big x value, you can just like, x squared term will dominate your numerator. Does it make sense? And what about denominator? Same situation happen, okay? When x goes to infinite, x cubed goes to infinite, and also x term goes to infinite as well. But if you think about the speed means even like both of them is getting bigger and bigger and bigger. But as long as you have like a more bigger power, then it is faster than the other guy. Okay. So again, when you compare x cubed and x cubed will dominate your denominator. Okay. And I'm going to say that is higher order rule in my class. Okay. Which means we're going to take the strongest guy from your numerator and strongest guy from denominator. And that's it. Okay. So let me rewrite this one by higher order. X goes to infinite. Just strongest guy of the numerator and strongest guy of your denominator. That is possible, okay? So, like once you make like this way by higher order rule, then we can just simplify like this way. And then this is equal to limit x goes to infinite minus 1 over x. That's exactly the situation, right? So your denominator is getting bigger and bigger, bigger, but your numerator is just number. Then your answer is equal to 0, okay? What about B? Well, if you took calculus from high school, you know the answer already, okay? As long as you have like the same power, the leading term has same power, which is x cubed, top and bottom, then the coefficient of your answer. That is true, okay? But also you can explain this one by higher order rule as well, okay? Okay, HO stands for higher order, okay? Okay, here we go. By higher order, just take the strongest guy from your numerator, which is 4x cubed, and strongest guy of your denominator. There we go. Then we can just cancel these guys, okay? Then it is 4 over 2. Then I can say your limit at infinite is 2. Here we go. This is a little bit complicated problem, okay? But but again, when x, whenever you have to evaluate the limit, even x goes to infinite, we're gonna try to start from plugging in, okay? Plug in infinite. Then what happened? Look at that. Infinite minus. Oh, what is infinite minus infinite? Do you want to answer by 0? No, it's not true, okay? But it is case, but it is not always, okay? But which means if your positive part, the first infinite is faster than the other one, then your answer must be plus infinite, okay? But what about the other case? If your negative infinite is faster than positive, then your answer must be minus infinite. That's what I explained like about the speed, right? But like the case whenever they have same speed and they will converge to, I don't know about 0, it could be 0, but like it will be just a real number. Is okay? For this case, they have same speed. Look at that. Square root of 9x squared, which is like first degree, right? And 3x, negative part is also first degree. They have same speed, then they will converge. Where? I don't know. So now, well, actually, like this problem has the like special number, which is indeterminate difference form. Okay, but we will discuss about this later. Okay, but anyway, we can evaluate this one by current knowledge. Okay, here we go. So now, what we're going to do is we're going to write this one as a fraction form. Then we will multiply the conjugate as we did in the like previous form. Okay, it is similar. Okay, here we go. So it is limit x goes to infinite, square root of 9x squared plus x minus 3x and over 1. Okay, as we did it before, we will multiply the conjugate of this guy. Okay, 9x squared plus x plus 3x. Whenever you multiply something on your numerator, do the same thing on your denominator. Is that clear? Then now, limit x goes to infinite. Let me write denominator first, okay, because there is no change for this guy. 9x squared plus x plus 3x, okay? Numerator. You can just simplify it, or a plus b, a minus b, right? So which is 9 square x squared minus 3x squared. Is okay? Okay, let me simplify your numerator, okay? It is equal to limit x goes to infinite, 9x squared plus x plus 3x. What about numerator? 9x squared plus x minus 9x squared. Dun, dun, dun. That's gone, right? So, it is equal to limit x goes to infinite, x over square root of 9x squared plus x plus 3x. Now what are you going to do? Now we're going to use the, since it's limited infinite, we can use higher order. Okay? But numerator is just one term. Right? But denominator is a little bit tricky. Who is the like strongest term of your denominator? Look at that. It looks like this one, right? But not only this one, but also this one. Let me tell you why, okay? We have the square root, which is 1/2 power. Square and 1/2 power, which means this is first degree. This is half degree. So this is like a not strong enough and it will be gone. So like this will be survived. But also this guy, which is first degree, okay? Both of them must be, we have to keep both of them, okay? So this guy can be written by square root of 9x squared plus 3x, okay? So now it is a little bit tricky, okay? I have to explain this one very carefully. X over square root of 3x squared plus, because 9 is 3 squared, then we can combine as one perfect square, right? But wait a minute, like, do you remember this one? Square root of like 3x squared, it is 3x? My answer is no. It is important. Okay, let me give you one important note here, okay? Here we go. Square root of x squared is equal to x? No, okay? It is absolute value of x, okay? It depends on the sign of the inside. Does it make sense? Okay, don't forget this, okay? So, like this guy is equal to absolute value of 3x. Sometimes this is really sensitive, okay? But like this one, look at that. X goes to infinite, which means like big, huge positive number, right? So this is positive number. 3 times x is positive. So without absolute value, it doesn't matter, okay? So this is equal to 3x, okay? You can skip this one, but you cannot, okay? Because just in case if you have negative number, it must be negative 3x. Okay, that's why I would love to teach you this one. Okay, so now let me come back. It is equal to limit x goes to infinite, x over 3x plus 3x, right? Which is equal to limit x goes to infinite, x over 6x. And then we can cancel this, guys. Then the answer is 1 over 6. Let me try to explain this, guys, by higher order rule. Okay, so here we go. So let me apply the higher order here. Then your limit will be written much simpler way, okay? But keep that in mind, this higher order is working for limited infinite only, okay? There we go. Like most of you know the answer already, right? But like this guy, we can just simplify, then we can clearly view like what happened here, okay? It is equal to limit x goes to minus infinite, x squared over 1, okay? When you plug in minus infinite here, plus, right? Doesn't make sense. What about second one? In the previous problem, I talked about this already, but like, let me emphasize one more time, okay? Square root of x squared is not x, but absolute value of x, okay? Don't forget this one. That is extremely important thing, okay? Here we go. So by higher order, x goes to minus infinite. Numerator is 4x to the 6 and minus x cubed. Is that okay? Then let me take care numerator. X goes to minus infinite and 2x cubed square. Is that clear? Okay. Then look at that. Square root of like this one. We just talked about this one, right? This guy is not just equal to 2x cubed, but this is equal to absolute value of 2x cubed. As I told you, you have to think about the sign of this guy, okay? Look at that. Your x goes to minus infinite. It is huge negative number. Negative number cubed is still negative, times 2 is negative. Oh, we just figured that out. This part is negative. Okay? I'm talking about negative. Doesn't make sense. Right? Then since the inside of absolute value is negative, you have to make it positive. How? Multiply another negative. Is that clear? So this one is equal to limit x goes to minus infinite minus 2x cubed minus x cubed. So when you cancel out everything, this guy and sign as well, so your answer is 2. Is that clear? What about this one? I will do same thing, okay? Let me apply the higher order first. Then this limited infinite will be written in a simpler form. And 4x, right? So let me take your numerator, but like look at that. Square root 3 is not, like 3 is not perfect square. Then just like let's like separate your limit, okay? Square root, okay? Square root 3 and x squared and 4x, okay? We're gonna take care this guy. As I told you, this is the absolute value of x, okay? Since x is positive, simply x, right? So that is equal to limit x goes to infinite square root of 3 times x over 4x. Cancel these guys. Then the answer is square root of 3 over 4. Okay, let's talk about this problem, okay? And this is my famous problem. When I taught this course, like I always put this problem in my exam, okay? So like these are concerned with exponential function. So look at that. Like I would like talk about this function, okay? So like as long as you know the graph of this one or behavior and endpoint behavior, everything is easy, okay? So look at that. So the graph of this one, dun, 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 that's it, okay? So what does that mean? When x is getting bigger and bigger and bigger, then your y value of this function is like infinite as well. So we can say e to the infinite is equal to infinite. But more important part for this problem is this side. Again, exponential function never be negative, but getting approach to 0, okay? So when x goes to minus infinite, then it is getting approach to 0, which means e to the minus infinite equal to 0, okay? But not only like base e, but also like, with base bigger than 1, happens same thing, okay? So like, don't forget this, okay? We're gonna try to use this guy, okay? So look, let me come back to the problem, okay? Look at that. G. X goes to infinite. Can you try to find e to the minus infinite term? Yes, you can do it. Here we go. This guy is e to the minus infinite by plugging in x goes to infinite, right? And also this guy. Since we know these two terms are 0, then you can just like ignore about that part, okay? So let me rewrite my problem. Limit x goes to infinite without zeros, 3x over, okay? Then there's no problem to cancel this guy. Then your answer equal to just simply 1, okay? And let me try to like apply the same thing like for h, right? So look at that. Same function, but like direction is different, okay? X goes to minus infinite. Then which part equal to this one? E to the minus infinite. You're right. I'm talking about this guy. By plugging infinite, it will be e to the minus infinite, which equals 0, okay? And also this guy. Is that clear? So since we figured like it is 0, and forget about that part, but let me rewrite your limit without 0. Okay? Minus e to the minus 3x over e to the minus 3x, okay? Then there's no problem to cancel these guys. Then your answer is -1.